So today's stamp is a nice challenge. It's a nice wrap up of everything we've been working on. Your tests are half graded. I will have the grades by 2:10, so feel free to stop by and find out. Front page and the second page looks pretty good, so hopefully the rest is just as nice. So this stamp we'll check first thing tomorrow morning. So you can show it to a neighbor, put it in the pocket of your folder, and we will visit it again first thing tomorrow. Yes? Mm-hmm. So good question. So she said the line on the stamp that says that the domain is negative infinity to infinity, it is a piecewise function, so it's going to be made up of pieces. But when I look collectively, when I look from left to right, it's negative infinity to infinity. So like where I have one empty hole, there should be somewhere a solid that fills it in. Okay. All right? Great question. So let's start looking at our first real-world scenario. Our objective for today is that we will learn how to model real-world scenarios using our piecewise function knowledge. So exciting. So what's great about this is that you already know how to do 90% of it. The 10% new piece is just that it's now set in a real-world situation. So go ahead and read your first scenario about tolls in New Jersey. Toll booths. Toll booths are how they pay for highways. Are there anything like that? I feel like there are. New York and Boston for sure, and Jersey, obviously. But Connecticut? No? But they don't belong to Connecticut. They belong to Boston. Very interesting. Back to our situation. Read. Yes. Focus. Okay, the value of tolls on the New Jersey Turnpike is based upon the number of miles traveled. We have our piecewise function T of X defined here. How many parts to our piecewise function? 2. Can be used to calculate the cost of traveling along the New Jersey Turnpike, where X represents the number of miles traveled, rounded to the nearest mile, and T of X represents the cost of the toll in cents. So even though there is no defined variables, let's do that off to the side. So X represents what again? Number of miles. And T of X, cost. In cents. So even if we're not asked to define variables, we're always going to do it. It's going to be a nice framework for everything else we talk about. I need to sketch this graph. Any thoughts? Remember, we know how to do this. So what would I do first? Yes. Sure. Let's label our axes. So we've got number of miles here. And cost in cents. All right. Someone else has thought first. Hold on. Did you have an idea? No, that was yours. Who else had a thought? Quinta? Write the piece out. That's what we did before, yes? So what's our first piece? So we're going to write 3x plus 15, where x is between 0 and 95. Now what? What next? We wrote our piece out, including the restriction. Fantastic. Marvin? Find my points. What should my choices be for my x values? Go for it. Very good. Let me know if our points match. Three times 0 is 0 plus 15. We good? Okay. Questions? Yes. We'll see. Good question. So her question is, should we go up to 300? We should finish finding all of our points first, and then we'll have a solid idea of what our axes need to be. Yes. We'll get there. So she has a point. 300 cents is technically how many dollars? Right. But let's finish getting our values. So we did one piece, right? Are we done? No. Go take care of your other piece. Let me know if the blinds need to come down. Yes? Okay. So I'll take care of that while you take care of the second piece. Thank you. Yes.
All right, never mind. I'll ask you.
Do we match? Mm-hmm. Yes. Question?
So you know how on the first one it says 95, 300, and then on the second it's 95, 320. How's that? Because you can't say two different things.
Great question. So what Cassidy is picking up on is that we have 95, 300 and 95, 320. So how can you pay two different prices for 95? Let's see what happens when we graph, and we're going to come full circle to your question. Right? So talking about graphing, how are we going to graph these points? What are we thinking? Let's talk x values first. I'm trying to get from 0 to 112, 120. So what are we thinking? 10? So this would be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50. All right, that'll work. I have to get to at most 110, 112, so that'll be right there. Nice. And how about for cost? So coming back to Jasmine's point, do I have to get to 300, or could I treat that as $3? Or is $3 the same as 300 cents anyway? 300 cents and $3 would be the same. Yes.
Like they're the same thing, but if you were to go by like dollars, wouldn't it make the intervals different?
No, as long as what each means is the same. So like let's say I counted by 10 cents, right? So this would be 10, 20, 30, 40, 50, 60, 70, 80, 90, $1. Now we have to get up to $5, so that's not going to be enough. So maybe I should count, instead of counting by 10 cents, I count by 20 cents. 2, 4, 6, 8, 10. So $1 and 100 pennies is the same. Right? And you're still counting by cents, right? Because that's 20 cents, 40 cents. So 2, 4, 6, 8, 2, 4, 6, 8, 10. 2, 4, 6, 8. Is this going to work? Woo! Uh-oh. Uh-oh. Nope. So now what are we going to count by?
25.
Let's try counting by 25. Count by quarters. So that's why we do it in pencil. So sometimes people look for like an exact science in terms of what to count by. A lot of it's an art. Try it. If it doesn't work, erase it, try something else. So 1, 2, 3. So there's $1, $2, $3. Yep. This is working out better, right? Okay. Let's start graphing some points. 0, 15. Is this going to be an array or a segment? I have too many? 1, 2, 3. Oh, yep, one too many. There we go. Okay. Segment, good. Is 0, 15 going to be a solid dot or an empty dot? Solid. So 0, 15. So here's 25. So really we're like right here, halfway in between 0 and 20 cents. 95, 300, which will also be a 95 and $3. Solid or empty? So 50, 60, 70, 80, 90, 95 halfway. Up to 3. Yes. Yes. Piece 1 accomplished. 95, 320. Open or closed circle? Ooh, open or closed? Open. Because this is strictly less than. I do not have equality right there. So 95, 320. To the best of our ability, we literally sketch that open circle. It's almost in that same, trying to fit in the same box, right? And my second ordered pair, 112, 507, solid or empty? Open or closed? Closed. So here's 100, 110, 112 will be roughly right there. Up to 5 and a little bit. Okay, guys, so now that we have our graph complete, let's see if we can answer Cassidy's question about can we have two values for 95, and then answering B, C, and D. Has anyone figured out the answer to Cassidy's question about can we have two values? I've heard from Marvin. Jasmine? I can? Why?
That's just, like, domain thinking, that's just filling in the, like, the open circle, so.
Correct. So one of these technically doesn't exist at 95, is what she's saying, right? So what would the actual cost be for 95 miles? 300 pennies, which is? $3. Yes? Awesome. All right, let's answer some follow-up questions. Find the cost of getting to exit 7A, mile marker 60.9. and getting off at exit 11, mile marker 93.4. Thoughts on how we're going to approach this? Olivia? True. So we're definitely going to do some substitution, which is great. But we're given a starting point, yes, at 7A, and then I'm get off at exit 11. I have these mile markers. So how can I figure out, like, how far did I actually drive? Linda?
The restrictions, you know how you have two equations?
Yes.
You're gonna look at the restrictions and whichever one you fit into, you use that one.
Good thinking. We are gonna need to substitute. We are gonna need to pay attention, but to the restriction. But I still don't know where I fit into the restrictions because I don't know how far I've driven. Michelle? I mean, Malaysia. I'm sorry. Thinking. Yes. Subtract what?
93.4.
Yes. Subtraction is the key. We need to actually figure out how far we've driven first, and then we know where we fall into the restriction. So the subtraction is going to be what? She's 100% right. What am I going to subtract? Let's find out how far you drove from that exit to that exit. What was it? She got 32.5. Who else got 32.5? Awesome. So now that I know how far I've driven, where do I fall in my restriction? We fall into the first one, between 0 and 95. So now I know that we are going to substitute into our first piece. So it'll be 3 times 32.5 plus 15. Figure that out. Let me know what you get as an answer. 112.5. Are you paying $112.50?
No.
No? What are you paying? Yes. So $1 and how many cents? Do you think the toll booth is going to round down or up on that 5? So $1.13. Very good. Work on C on your own. Find the cost of traveling the entire length of the Jersey Turnpike, 112 miles. The question was, do we even have to do anything? Why is she saying that? We already did it. Did you not already up here substitute in 112? Yeah. And what did you get as an answer? Which is how much money? Very good. So we can be strategic and utilize work we've already accomplished. Now, worst case, if you didn't see that you had already done it, that's okay, right? Do it again. You're still going to get 507. Nice job. Approximately how many miles would you need to travel to have a toll of $2.50? Interesting. How are we going to figure that out? Jasmine. Let's do that. So she says go to the graph. Would I be looking at the x-axis or the y-axis? So 250, which piece will I be in? The first piece or the second piece? So that means we're going to take and we're going to use this second piece. So what equation can I set up using the second piece? $2.50 equals 11. No. Wait. Sorry. I pulled the second piece. $2.50 equals 3x plus 15. So what she outlined as the approach is absolutely correct. I realize that I have a value for y. I have a f of x value. So we go to that axis and we ask ourselves, what piece are we in? That will tell me which equation to use, which in this case is my first piece, 3x plus 15. Let's solve this. Good question. So the question was, can we just look, trace down, and figure it out? These are big jumps in miles. So let's say I estimate, so 2550 is here. I think it's what? What would this be? 80. It looks like it's 80, but could it be 80.6? Or like 79.786, right? So we have an estimate. So if I ask you to estimate, 80, perfect, done. But we're asked to actually find the miles. So we're going to calculate. Great questions. Subtracting 15 from both sides, what do we have on the left? Equals? Good. Divide by 3. Something happened. No. Yeah, Marvin, what happened? Anybody else catch that? Doesn't make sense to be getting a negative answer, right? So what went wrong? We left the decimal in, but what does that mean? Marvin, can you say that again so everybody can hear you? We have dollars, we need cents. So we can't be using 2.5. So let's try it again using 250 and see what happens. True, but our values are defined in cents. So that's what our piecewise function is, working in cents, not dollars. What are we getting for miles? So our estimate of 80 was close, but our exact answer, you traveled 78.3 miles. Very nice. Let's look at our second scenario when you're ready. Still an approximation because 0.333 repeats forever. Let's read number 2. Cost of a speeding ticket is related to the number of miles per hour that a driver is caught traveling above the speed limit. Common sense. We all have an idea of that. Speed limit on a section of I-91 in Windsor is 65 miles per hour. Consider the following hypothetical rules. If the driver is caught traveling less than 5 miles per hour above the speed limit, a warning is issued. There is no fine. If a driver is caught between 5 and 14 miles per hour over, the ticket's $120. 15 to 24 miles per hour above, fine is $15 per mile per hour over 65. And if a driver is caught traveling 25 miles per hour or more, $450 fine. Woo! That's a lot of money. So how many pieces? Yes, Cassidy?
So if you're only driving like 17 miles above the speed limit, it will only be like $30.
There's a rate involved, right? So she said if you're only driving like 17 miles over, it would be how much are you thinking?
30, and it's only 2 above 15.
30. So it's going to fluctuate in that piece. We'll see in a second. Yes?
But wouldn't it be because it's 65 miles, wouldn't you multiply that by 15?
Let's get there. Let's take it piece by piece. We're starting to talk about different pieces. How many pieces is this piecewise function going to have? 1, 4. It's going to be 4. Because we have to account for less than 65. So let's talk about piece by piece. If the driver is caught traveling less than 5 miles per hour above the speed limit, a warning is issued, but there is no fine. So what would that piece look like, and what would the restriction be? Constant at what? 0. Let me put this in something other than black. So 0, and then when is it 0? What do I write? Less than 5. So at 5, technically, no, listen, so it just says less than 5, right? So if you're at 5, is that less than 5? Think about that. Very good. So this is going to be x strictly less than what? Yes. There's no equality here because 5 picks up right here. If a driver is caught traveling 5 to 14 miles per hour over the limit, the fine is 120. Is this going to have a rate, or is it constant? Constant again, so 120 when your speed is between what and what?
5 and 14.
Do I have equality on here? Yes and yes. Now let's talk about this third one. Drivers caught traveling 15 to 24 miles per hour over the speed limit. The fine is $15 per mile per hour over 65 miles per hour. Yes, Olivia? When x is between what and what? Now, where the only issue we're having here, right? Where one ends, the other is supposed to pick up. I don't know about this. Could we do that? Now, if we do that, so she said, can't we turn the x into a 5? If we do that, how does x need to be defined? The miles per hour over 65. So whatever speed we work with, if this is how we're going to go, which is perfectly fine, we need to make sure we understand that x will be however many miles over 65. Okay, so now we're in better shape. 5, 5, 14. Uh-oh. What happened here?
We need to add the equality sign.
Well, see how 5 picks up with 5? I have strictly, but then I have my equality. Here, 14 is definitely accounted for. What are we thinking? So the consensus, Vince? Well, where does the equality belong? Based on these definitions, we do need to leave the equality with 14 because this strictly says 5 to 14. Fact. Yes. Don't make this one equal to. Right, I agree with you. Because it picks up, this cost for you picks up at 15, not 14. Very good. So what about this 24? Is this 24 going to have equality? Yes. Very good. Drivers caught traveling 25 miles per hour or more above the speed limit, the fine is $450. Constant or a rate? Constant. So $450, comma. What are we going to say for our restriction here? So how many pieces do we now have to work with? Go ahead and start working on that graph. Take one piece at a time. 3 of these should be quick because they're constant. Putting all your pieces together. Yes. Good question. Can we change the speed to be aligned with how we decided to work with this? What would let's start with where 0 would be. We can change this. I'm fine with that. We could? So what's the vote? Do we want to change our scale or do you want to change the restriction? Want to change the restriction? Okay. So if we were to change these restrictions, X would be less than, isn't this so much fun? All this thinking so early in the morning. X less than 5 would become what? Okay. 5 to 14 would become, right, so where they're getting that, 65 plus 5 is 70, 65 plus 14, 65 plus 14, 79. So let me say that again. 65 plus 5 got me 70, and then 65 plus 14 got me my 79. 14 and 24, so 65, well, if this is 79, what's this? 79. And then 24 becomes, what 2 points are you choosing for your first piece? 70 and what? 65, 60, either work. True. So check this out. So let's do X to 70. What's your second point going to be? Give me something less than 70. 60? Let's go to 60. So I'm told when X is 70, what's Y always going to be? 0. Now you're right. It says strictly less than, right? So that means that when I graph this, is this going to be an open or closed circle? Open. Mhm. Ah. Yes, sir.
Good morning, East Hartford High School. Please excuse this monthly safety announcement. To all students, you should be really careful about what you bring to school. Any weapon that could be used to injure others cannot be brought to school and will not be tolerated at East Hartford
We definitely have time, so keep graphing.
Having items such as this in your possession, as well as drugs and drug paraphernalia, will result in OSS, arrest, and possible expulsion. Please make the right decisions when it comes to this, as well as maintaining positive peer relations. East Hartford High School is not the place to have arguments, disputes, or fights. If you find that you have brought something to school that is against the rules, please report it to an adult immediately, and administrative guidelines for discipline will not apply. We will continue to be firmly committed to maintaining a positive, safe climate conducive to learning for all staff and students. Be responsible, be respectful, and be safe.
Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Students are reminded to be responsible by being on time and in uniform.
Ladies, homework is to finish the last one.
Treating others with kindness and to be safe with words and actions.
So how many constant pieces will this have, and how many non-constant pieces will this have? So we should end up with 3 constant pieces, and we're going to have 1 non-constant in the middle. So when you plugged in 79, what did you get out? 120? So I'm going to do 79 times 15. Did I write something confusing? That doesn't sound right. What did you get here? That's not on our graph. Marvin?
We're adding unnecessary miles.
How are we adding unnecessary miles?
Because we're slow. Because 65 of those miles don't have to count because they're not above the speed limit.
How are we going to account for that? Subtract 65 from what? You all understand what he's saying? Yeah. So I'm going to make that a challenge for tonight's homework. Whoever figures it out, it's an extra stamp for the morning. Follow? Say it again.
We're adding unnecessary miles.
So what was the idea on how to fix that? What's that actually going to look like? I'll tell you first thing in the morning, but I want you to think about how you can make that work. But you understand what we're doing, right, with each of our pieces? Yes? Yes. No shaking your head, no. So the third one for tonight, any questions on this one, send me a remind, right? We'll pick up on Marvin's points for this piece first thing, and if anybody wants to bounce ideas off me through reminds at some point today, stop by and we can talk. Nice job today. I will be after for about a half hour after school. So if you'd like to come see me, come see me. Nice job. Have a good day. Yes. Yes.